Today we will have a lot of fun by programming the AI. We will program an enemy and we will program the behavior of a friend. Okay, so yeah, let's have a little bit review of what we did in this script, in this skeleton, in this AI agent. Wait, this is not the thing. This is the thing we do. Okay, this is the thing. This is the thing. Let me find you skeleton. Last time we create this very simple navigation test to let you know how can you use the navigation map to move the character around. And it's actually pretty easy. You just need this one statement. Okay, that better. You just need to use this one statement, nav agent dot set destination, and you gave the position, which is from the transform of that game object you want to move to. So it's this that is a game object, and transform is transforms position. Okay, then it will make it move automatically. So that this is pretty awesome feature that save us a lot of work. If you want to program walking and you try to decide which way to go, that's actually plenty of work. Yeah. And don't forget, you need to have this nav mesh agent attached here, attached to that character. Either it's enemy or friend. You have to have this navigation mesh agent, and this animation part, yeah, that's because we want to have some effects there. Alright, so that's a simple test of the nav mesh, and today we will build upon this. So what we want to do is, okay, let's think about an enemy in the game. Okay, from your previous experiences, what do enemies do in the game?
Attack the player?
Yeah, attack the player. Yeah, one is attack and
move.
huh?
They move or follow the player.
Follow the player. Yeah, the kind of patrol around and trying to search for the player or search for the player's friend. That, right? And they attack, they search. What else?
Avoid obstacles. Avoid obstacles.
Avoid obstacles. Yeah, that's part of patrol. When you patrol around, you kind of need to avoid the obstacles. Yeah. Sometimes it's a patrol, attack. Also, you also have an idle, right? Like everyone else, like everyone, right? Or idle. Yeah. Even when we're in a class, we have some idle state. Right? I can tell.
They can communicate with other AI.
Communicate.
Alert
Yeah.
them that you're there or whatever.
Yes. Yeah. That's somehow that's some internal functionalities. You won't actually visualize that a lot. Yeah. So what we are trying to do is first idle, then we make it guard. So we make it patrol around, and then we make it attack. That's three different things we are trying to do now. Also, you can do flee when they are fighting, or when they are when the enemy may lose. Sometimes just hit the enemy to death. Sometimes the enemy can run. So yeah, and the flee. So that's for basic functions we are trying to do today. Maybe not flee, but the important part is the fight, the combat, and the guard. Also, idle is just animation there. So okay, let's finish. Let's do that one by one. All right. So we will forget about this move to function in this update. Okay. What we want to do is first we want kind of decide some enum. Enum, maybe it's state. So it's idle, and what else? The guard. Maybe flee. Sorry. Flee. Okay. So we have this state. So whenever the character or the enemy is in one of the state, we want it to do something, right? So that if you think about this mono behavior, everything is actually important. We need to have some place to trigger that. So most of the time we do that in update, because that's basically every frame you call that function. So AI states. So we have a, yeah, I think we have a case or something. So we won't have a function. Function called run these behaviors. So we will call this function in the update. Run behaviors. So guess what do we want to do in this function? We use this behaviors, different behaviors, to judge what kind of behavior we want to go. So what we do is we use a switch. So it's yeah. We need another variable here to hold the current state. AI states current state. Okay. Maybe we won't give you some initial value, like AI states dot, maybe the idle. Okay. So here we will use that variable. You can see that, right? You can see that clearly. All right, cool. So we use the current state. We use this variable to decide what do we want to do here. So it's like this. then it's yeah, case and behavior. This is the behavior. Yeah, when we're doing idle, we want it like run the idle. We're not implement that yet, so we will go ahead and implement that part. And the same thing here. In case guard, what we want to do is to run guard break. Okay, things like that, and also something else. We will implement that later. Okay, and then here when we are yeah, and here in the S update, kind of you need to have the sense you forgot to put this here. So this works this way. Every time when you get into a frame, you will run these behaviors. You will check what is my current state, and according to each different current state, we will run that state. Yeah. Okay. So the next step, we will see how can we implement this actually state. Actually, when you are in some of the state, you can do like transfer from one state to another state. And when you are doing the patrol, if you find an enemy, you change from the patrol to attack. So that's something we need to take into consideration when you are implement that. So you kind of need some map or some of the strategy, some of the the structure of your AI. So usually you do this like kind of like the decision trees or the combination of decision tree and state machine. So you kind of have this idle. Idle and guard. So maybe and this is like the top level, and if you go deep inside, when you're doing idle, what you do is the idle animation. Idle animation. And when you're doing the guard, kind of doing this search. Okay, maybe they have different order. But yeah, so when you are doing this guard, actually you have two different ways. First, when you do guard, you control the path, and when you see some maybe when you feel that the enemy is within the range, you kind of need to change to the search. When you search for that enemy, then you can get into that combat, the attack function. So yeah, that's kind of the thing we want to do here. So run idle will be pretty easy, right? So run idle. sometimes you want to make it more layers. So, but here you won't see the difference because void here I make it one more layer because I may need to do something that actually when you run idle, it's not all things about idle. Maybe you want to do something different. So here I leave that possibility here. So I made one more layer here. So the actual idle will be implemented here in this idle function. So I think it's just play the animation. Yeah, animation. Animation, then we play. Let me see. The idle is uppercase, lowercase. Okay, yeah. Well, actually, when we're doing the idle, we actually play the dance. Dance. Okay, so that's the idle. And we were doing the same thing here. Run guard. We will implement this as well. Yeah, so we were talking about guard. Actually, we have two different things there. One is search, one is patrol, right? So we need something like to decide whether do we want to go search or patrol. So we need another boolean here. Is suspicious. Search for target, right? If the distance is less than something and okay, let's first do this part. Although there are a lot of variables, I haven't do that yet. But basically, what does it mean here? So when it is suspicious, means we want to try to make it like search. Right? So when you're suspicious, sometimes when the enemy is walking around, and the AI is walking around, is trying to find his or her enemy. Sometimes you cannot just see the enemy in your range. Sometimes maybe the enemy put like is shooting you from behind a wall or something like that. So you get hurt. You get the HP level reduced. So at this moment, the AI usually is gonna be in a state of suspicious, right? So you cannot see the enemy, but you get some HP reduced. So you're attacked you're attacked from nowhere. So you are in the suspicious state. Then if you're in the suspicious state, you want to search for your enemy. So you search for the target. We will call another function to search for that enemy. However, when we search, after we search, right? Like we walk around, we're just trying to search the enemy. When we're doing the search, when does the search end? The condition is, I find the enemy. I find the enemy. And the enemy is within the range of my attack. Then we can actually we can change behavior to another state, to the combat, to the attack state, right? So that's basically what we are doing here in this if statement. And if you look at this structure here, we actually have a control around the task. So that's also another thing we want to do. If it's not spacious, if you are not in the spacious state, so what you do is just this, right? It's else. So it's gonna be patrol. Yeah, I know everything's not here yet, but we will reach there. Patrol. So this logic is pretty clear here. When you're doing the guard, you kind of need to make a decision between those two. So how do you make the decision? You use this suspicious this thing. So we need to define as is suspicious. Right now I'm defining everything as public, so I want to change it in the inspector. So yeah, but in actually game, sometimes it's changed internally by some other trigger, some event. So you don't have to do that public. But now I'm doing this public. Suspicious. We initiate like false, right? And what else do we need? Search for target. Yeah, it's another function. Let's make it to be implemented. Okay. And distance. Distance is, this distance is the distance between that character and its enemy. We want this float. And we kind of want to give it some value that is maybe it's a bigger value here. Yeah, and another boolean is in range. Kind of need to set up it in some give it some initial value so that we are not triggering anything yet when we're running that. And then this change behavior. Also, we need to have a patrol functionality. Okay, so that this is the guard function. We only have, right now we have a frame of it. We have a structure. What do we need to do when we're doing this guard? And we still have some functions we need to implement, right? One is actually search. What do we do in search? What do we do? We are doing patrol. And change behavior is kind of easy. Okay. So we do have this idle. Idle is play the dance animation. That's pretty simple. And let's see, how do we search for the target? Okay, so if you want to implement this search for target function, what do you think is there? So I mean, make it clear, when you're doing search, you need to let's make it simple here. So we just want to make the enemy, make the AI running towards that target. So suppose we already know where the target is, to make it simple. And we have a name match there. So what do we do here?
Would you need to determine the distance between the target and the enemy in like an update function, and then it's within a specific distance, set it to run towards?
Yeah, in update function, yeah, that's right. So when you say in update function, yes. You remember in our update function, we actually have this run behavior is called, and everything here will actually be called in update function. So you don't have to like think about put them into update. So here every function here will be called, and so in update function it basically just loop through and see what is the current state. And if it's guard, it's going to do the search. Right. So here, when we're searching for a target, probably first thing you want to do is think about how do we implement the idle. You remember? How do we implement the idle? We play the animation. Right. Yeah, well, the idle either is just standing here around, or what we're doing right now is dancing. And yeah, if you think about the search, what animation should be played there? Running, right? When you search for some target, it's either walking or running. But now, if you look at our list of animation, I don't think we have a walk. So we will use this run. Yeah, we will use this running animation. And then what do we need to do? First we play the animation. Then what we're trying to do is we use the name match to put the target as the destination. And then what we need to do, if you look at there, when we're trying to call the search for target, the next thing there is we judge the distance. So when we're doing the search, we need to update that distance continuously, so that we know the distance between the AI and its target, and then with that distance, we should be able to change behavior accordingly. Okay. So here. So first is animation, right? So you kind of get component animation play run lowercase or lowercase, yeah, play animation run, and destination, search for the target. Yeah, we need a variable to hold the target. No, not here, or the destination. That's fine. We already have destination defined. Okay. Yeah, we'll use the destination. Name to the destination. So we have destination. How do we find the destination? Is game object find game object with tag, if you remember. Since we are trying to define an anime AI here, so the anime is search for the target you control. So we will use this character as a tag for the search. Okay. Find object with tag character, and then what else? When we are trying to do the destination. Yeah, we need to transform on that position, but since this is defined as game object, so we will do this. Vector 3 destination. And position. Yeah. So we have a destination here. And then what we do is naive. If you remember what we do in last class, naive agent set destination, and what do we put here? Destination, right? And then what do we need? We need kind of yeah, so this actually make it naive to the destination. And number 3, what I mentioned, we update the distance continuously, right? Because we're using the distance to judge if we need to change to another state. Okay, so we update the distance. How do you calculate the distance between two positions? Mathematically, two vectors.
Subtract the destination from the position and the current position.
Yeah, when you subtract, that's another vector. That's the direction. If you want the distance, that kind of a formula there. If you don't remember, that's fine, because this function have been used so frequently. So we have another way to do that because it's predefined already. So we just need the vector 3 distance, and you give the 2 vectors there. Otherwise, if you want to calculate yourself, that's pretty easy. If you don't remember how to do that, you can go back to, I don't know if you learned that in high school or some but yeah, I think I learned that in high school somehow. Okay, so it's myself's precision and the destination. Yeah. Destination. Cool. Alright, so we update the distance, and then if the distance kind of change is in range. Do we need that part? Actually, yeah. Search for target. Actually, if we are doing this here, we don't actually need this here, but just in case something else called this function, we can actually remove it, because we already done that. Yeah.
You just change the behavior from the search target function?
What's your opinion?
Can you just change the behavior since you're checking the distance? Can you just set the change behavior function to call from is in range after that?
Yeah. So you can implement that way. It will work, but it will not be recommended, because if you can see here, we have different level here. So each level has its own responsibility. Of course, as maybe you have a president of a university, you have this administrators, you have other professors, lecturers. We are in different levels. We work on different things. Sometime maybe a professor can do something for the president, but somehow ideally it should be the president's responsibility. So it's not the search for target's responsibility to do that change. We will do that in this level. When we're doing the guard, we will change that behavior. Yeah, because here you're like kind of switch from this to this. So there is that. And if you want to change from here to here, you can do that as not recommended, because that will mess up finally in some place if you have very complex program there. Okay. Change behavior. This says okay. Patrol. Yeah. And then let's do this patrol. We know that yes, let's search for target, and then let's do this patrol function. So what do we do in patrol? Like the search. What is the first step when you do patrol? Yeah, animation. Okay. So basically we're doing animation every step. So first animation. Let's doing the same thing here. Get component. Right. Get component. Play run. It's also run because when your patrol is you're just moving, navigating. Yep. Okay, so when we're doing the patrol, we want it to patrol through some certain pattern in this thing. We want it to move to the door, then make it move to the computer, make it move to the back of the classroom, back to the door. We want to do the search around, do the patrol around this pattern. Right, and when you are doing the patrol around this pattern, when something happens, when you're suspicious, you change to search, and then when you find the enemy, you change to combat. So that's how it works. So first, it's playing the animation thing. Then we need to define some waypoints there. Some waypoints there to make it like this. Yeah, we'll do some waypoint here. Yeah, 1, 2, maybe we put another one here. Yeah. Let's make it somewhere else. Yeah, if you think about this position over here, if we do not set up a waypoint here, maybe an enemy can be hidden at the back of that cube, so that it will never be found. And then what we do is we put a waypoint here, so we force the AI to go through this pattern from this waypoint to this point, and then go this point, then it goes back to here and back here. So we want the AI to like patrol around this pattern. Alright, so here we want to make it waypoint 3. Waypoint 3. Yeah. Okay. And then here we need a data structure to hold that. Hold those waypoints. So I think we use array or something, those collections. Yeah. You can do game object. Game object. Yeah. We use array. Alright, because when we're using the waypoints, basically we're using the transform, the locations of the waypoint. So I guess, yeah, it's okay. You can put game object here for now. And we go back here. So let's see. Yeah, we are trying to patrol around the waypoint. We need to have a maybe initial. So initial target. We may just make the very first waypoint to be its initial target. But before we actually went there, we need to check if we are actually there or not. If we are already in there, we don't need to. We need to go to the next waypoint. Right. So let's check. First, let's check if we're within the range. There we have a distance. You remember the vector 3 and the what's that? The distance. Yeah, distance. It's the distance between me remember you cannot just give game object to the distance function. You need to give 2 of the vector 3-dimension vectors, and waypoint current waypoint dot transform dot position. Yeah, we have this index here. We haven't defined it yet. Let's make it int, because it's basically an index of an array, so it's int. Initially we put it as 0. We want it to start from the very first waypoint, so it's here. Yeah. So basically it's a distance. We give a value to the distance. We judge if we need to go to the current one or the next one. Because if it is in the current one, and we need to make it to go to the next one, right? So what we do is if this distance is less than 2. If this distance is less than 2, we will make the destination waypoint current waypoint at transform dot position. Right. So it's that we we try to detect how far is it. If it's far, okay, we set it as our destination. And you can guess when we have this destination, we use the naive agent, right, to set up the destination. Set the destination. Okay. Right. So this is the situation that we going to the current waypoint. However, there are some situation when the distance we already arrived there. When I already arrived at the goal, I want to go to this computer. So we need to go to the next. Go to the next. How do we do that? So we use this else. we make it plus plus and yeah.
Shouldn't that if statement be if distance is greater than 2? Because if you're more than 2 units away from any wind noise, then you're not going to move.
No. It's less than 2 if I want to see. When I get close to the door, it's less than 2 means I arrived.
Okay.
If I arrived, if I have already arrived. Oh yeah. This distance was continued. A little bit confused here. It's less than 2. Yeah, it's greater. Yeah, yeah. Thank you. Yeah, sometimes you got confused. Yeah, when it's greater than 2, go there. And otherwise, you set it to the next. So yeah, that's the way. So when you do here, 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 and also you have to consider another situation when you here it's a circle, we're fine, but here we go from point 1 to point. Yeah, I kind of want to make it point 3. Point 2. Okay, you go to point 1, point 2, point 3. You kind of want to reverse the path from point 3 to point 2 to point 1. You have to do that, right? So this is a logic. It's okay. It will work if you go to from 1 to 3, but beyond that, this logic will have some issue. So we want to also make it like reversed. So in this else, we consider not only this. Yeah, we will need another Boolean here. Kind of want to put it together. Reverse path. Initially it's force, right? So here what we want to do is if we're in a reverse path, yeah, so we need to consider a situation that is current waypoint zero. That's the situation we end this reversed path, and this is the situation we will do the reversed path. current waypoint minus and set up the destination to the waypoint current waypoint dot transform dot position. Right? Yeah. Okay. Yeah. So this is the reverse path. If we are in this reverse path, we kind of want to first detect whether we are in this reverse path, whether it's reaching the end. Because when you're doing minus, sometimes it go to, probably it won't go to less than 0, but it will reach 0 at some point. So when you reach 0, you do not want to minus again. It's -1. It's out of boundary of the array. So you kind of need to make it go back, go to the correct, go to the not reversed path, and that's here. That's the thing here. And this is actually the part when we're doing the reversed path. We minus and we set up the destination as the 3, 2, 1, 0. Remember, we start from 0, not 1. Okay, so this is actually the reversed. Let me put some comment here. The actual actions of going reverse path. And then yeah. So here kind of this if statement, and here this is the actual actions of normal patrol. Okay, of going along the waypoints. So yeah, because this if, so this will all go to another else statement with this if. But before we are doing this, we actually need another if statement. So it's kind of nasty here, but we do need to check those actions, otherwise there will be some issues. If, because it's corresponding to here, right? So what we were doing here is current waypoint is greater or equal to the waypoint dot length, if you know the length of the array, right? Is that correct here? It actually won't reach the length, right? The length is 4. The index is 0, 1, 2, 3. So there's no 4 in the index. So here we kind of want to do this -1, because it will reach the -1, then it will reverse. Here, when it reaches 0, it will reverse. When it reaches -1, it will reverse. Waypoint length -1, it will reverse. So here, reverse path equals to true, right? And then we need an else corresponding to this if. So we move this over here. Yes. So this is basically the patrol. The patrol of the AI. Let's look at this again. So first we do its animation, then we make it patrol along the waypoints. In order to make it patrol along the waypoints, we need to take into consideration of several things. First, if you are close enough or not. If you're close enough, some of in the current waypoints, you go to the next. Okay. But if it's not close enough, you go to the current waypoint. And then when you arrive at the current waypoint, you have to make a decision whether it's go forward or backward. Right? So whether it's forward or backward, it depends on your current state. We have a Boolean there, reverse path. If it's reverse path, we go backward. If it is forward, or if it's not reverse path, we go forward. And we need to change that reverse path variable here. So when there are 2 points, we want to change the reverse path. First is when it arrives at the end. So it's arrays length -1. If it's arrived there, we change it back. And if it's arrived there in the 0, in the very first index, then we change the reverse path, go forward. Okay. And then that's different things you want to take into consideration. So you use a kind of different if-else statement, different level to take all those into consideration. So that's basically our patrol functionality. We will try to run this functionality in the next class, and you will see what's going on there. Okay. So that's it for today. Thank you.